Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Tonight we're excited to kick off the rust and get you ready to go back to school with your TI-84. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. Tonight we're lucky to be joined by two friends of mine, Valerie Hudson and Karen Camp. Valerie is an educator with over 30 years of experience teaching middle and high school mathematics. Through her work with Texas Instruments Math Forward program, as an author of TI instructional materials and activities as a consultant through the Texas Instruments systemic in-school programs, Valerie loves to share her passion for technology as a vehicle for encouraging increased student achievement. Valerie, it's great to have you with us.
Great to be here, Michael.
And Karen was instructor of mathematics education at Yale University for 15 years and previously taught high school math and middle school math for 13 years. She's been a T-Cube national instructor since 1998 and has been author of materials for summer workshops and TI instructional websites. Karen speaks often on how to use technology effectively to enhance student understanding. Karen, I'm excited to have you with us tonight.
So glad to be here, Mike.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions to Karen or Valerie using the Q&A window on the right side of your screen. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Valerie is going to discuss our agenda.
Absolutely. So we've already had our welcome and introductions. We are going to then lead into tips for online teaching with TI tools, a tour of the TI-84 home screen and shortcut menus, the use of the TI-84 to develop understanding of functions, exponents, logs, and complex numbers, the transformation graphing app, coding a transformation, as well as TI Connect software. And there are multiple additional resources that you'll have available once the webinar is posted online. So if you don't have your calculator with you, that's fine. Please do not try to keep up, because this is an overview of all the wonderful things that TI can do, but you've got lots of resources to come.
Valerie, thanks so much. And Karen is going to discuss our expected outcomes.
So after the webinar, you're going to be able to say, I can use the TI-84 Plus home screen and shortcut menus. I can choose an effective graphing window for the situation. I can use function notation for graphs and calculations. I can, with my students, build an understanding of exponents, logs, and complex numbers. Open and use the transformation graphing app, code a randomly generated function, and get familiarity with the TI Connect software.
Awesome. Thanks so much, Karen. Karen, I passed you control. You should be able to switch to your current slide.
Okay. Okay, so this is my outline of the tour that we're going to take, my half of the tour. We're going to go over TI-SmartView and tips for online teaching, and then the other things that we had already mentioned, tours of the home screen, windows, function notation, exponents, logs, and complex numbers. In terms of tips for online teaching, I know that many of you will be in situations where you're doing some or all of your teaching online, and some of you are going to be doing some face-to-face teaching, so we'll try to hit the highlights in both situations. But some tips for online teaching: keep the SmartView emulator software on top of your working document, whatever that might be. Microsoft Word, Google Docs, a smart notebook. I'm playing around with Microsoft Whiteboard, so whatever you're using. Use screenshots frequently so students can keep up and catch up. Annotate them for asynchronous learning. Use color and motion to highlight ideas, and address misconceptions directly. You don't have the benefit, if you're online, of being in the classroom live and catching the misconceptions that students might have. So if you're synchronously teaching or recording something for later, make sure you address common misconceptions as you see them. And consider the SmartPad app for the TI-84 Plus calculator, which can control the SmartView emulator from a connected handheld calculator. And all of that, how to do that, is in our documents folder with some information. So let's go now to our SmartView emulator. And this SmartView emulator is an emulator for the TI calculators. TI has support available for Chromebooks as well as Macintoshes and PCs, and Valerie will tell us later a little bit about those details. But your SmartView emulator, if you've never seen it before, it's a working calculator. If you're in your classroom on your smart board, you can actually push the buttons directly. You can push Y equals. You can push second quit to go back to the home screen. You can type 25 times 17, literally at your board, or if you're using a laptop or a tablet, a laptop with a touch screen. This emulator has 3 calculator models. So right now we're using the TI-84 Plus CE, which is the thin profile calculator with a color screen. It also has, living in it, the TI-84 Plus C. And there it is. That was what I did there. And the TI-84 Plus, the grayscale. Okay, and so these calculators don't communicate with each other within the emulator, but you have the ability to display all 3 kinds for your students and whatever works for your classroom. Other things that you can do with this, you can show the key press history. So if I hit Y equals and then I hit graph, you can see these key presses come up down here. And one of the things I said about online teaching was to keep your, use screenshots frequently, keep your emulator on top. Under View, you can choose Always in Front, which means it's always going to be on top. And let's say I'm using a Word document. I can literally grab this screen and pull it to my Word document underneath. Now you've noticed that my Word document is covered by half of my emulator. You can change the emulator from what I have here, which is what I might use in the classroom, has a large keypad and a large side screen. This button here at the top menu is going to change it into a small keypad. And a small side screen, and there we go. Now you see you can just pull this screenshot right into my Word document. If you're in your Word document, you can choose picture format, and you can outline that screen if you want. So if I'm on my home screen, if I pull that in, it sort of floats there. So I might want a picture format border around it. And the other reason why I wanted to show you how you can pull it right into another document, whatever your working document is that your key press history, you can highlight your key press history, more than one. You can hold down your Shift or Control button and copy it. And then going back to your Word document, you can paste it right in. And this also works for a Google Doc. Whoops, I got to go back and get it. Copy. Nope, didn't work. It worked before. I tested this out. There it is, into your Google Doc. And also in the Google Doc, you can just pull your screenshot right in. So there's lots of ways that you can grab this. The other thing I want you to notice, if you're in person in your classroom, This SmartView emulator has these two, whoops, that's really big, has these two icons down in the bottom. You can move your calculator keypad to the right side or the left side. And if you're short like me and you're working in the front of your classroom on your smartboard, you can move your menu items to the bottom or you can move them back to the top. Okay, so now let's jump right into our tour. And let's say we are back here on our home screen. The mode button is one of the first buttons that I want you to notice, and you want to make sure that you're in math print mode, which is going to allow us to show mathematical notation. So what might you do with math print mode? Let's say you want to do some computing with fractions. One of the things that happens with students when they use fractions, if they just use the division button, it's fine, but they tend to make some mistakes. And it has to do with how the fraction bar can be a grouping symbol, and they might need to have parentheses. Let's say I wanted to do 1 over 2 plus 7. So 1 divided by 2 plus 7 is going to not group that 2 and that 7. I'm going to need parentheses. And so I can do second insert my parentheses, but students make mistakes with this. And so I think that one of the best things that has ever happened to the TI calculator is the fraction bar. You can find it in a few places. On the TI-84 plus CE with the newest operating system, if you hit alpha X, you get your fraction template. So 1 over 2 plus 7 will give us that. And if we want to do the addition that I did before, whoops, we do 1/2, arrow out of the bottom of the fraction template, plus 3/8. And it's going to give me my lowest form simplified fraction. Other places that the fraction bar lives is in the first shortcut menu. If you type alpha y equals, that's our fraction templates. And so any of the TI-84 plus family calculators has it under alpha y equals. Okay, so what might I want to do with this fraction bar? Let's go back to this function I have up in y1, x squared plus 6x plus 5. Let's say I wanted my students to use the quadratic formula to solve that, if that function equaled 0. And so if I want to use the quadratic formula, this is something that is factorable, but I just want to use it as our example for the quadratic formula. So that's going to be negative b, which is -6, plus or minus, we can't do two operations at once, but plus the square root of b squared, which is 6 squared, minus 4 times a, which was 1, times c, which was 5. Now, you might say, Karen, I can't even remember what function you were talking about. In your emulator space, you have something here called view cubed. And if we click on that, let me make this a little bit bigger. If I click on that, I'm going to be able to see my equation, my graph, my table. And so, let me go back to y equals here. Okay. If I want to get that cursor off of the x squared. There we go. Okay, so now we can see, and you can show the function at the same time as I'm working with it. And it's over 2a. So here we go. So my first solution to this function, the x squared plus 6x plus 5 equaling 0 would be -1. And I tell my students that mathematicians are lazy or they look for elegant solutions. I don't want to retype that. I want to arrow up and use the history. I arrow up will scroll me through past computations. Arrowing down scrolls me back down. I don't push the left or right arrow. And once I get to the entry that I want to work with, I press enter. It pastes it down here. and I can arrow around to get to the minus. By the way, you can see very clearly here that the negative symbol and the minus, the subtraction operation, are two different symbols. So that's something that your students, you need to give that information to your students. And here we go, the second operation was, the second root of this quadratic is -5. What else can we do with this quadratic? If we are interested in students factoring it, we can have them do the factoring and test it out. So if they put the factoring here, I'm going to actually make a mistake. Let's do it this way. Let me make the mistake that it factors into x plus 6, x plus 1. The graph that we had before was just of the quadratic. I'm going to arrow all the way to the left, press Enter, which allows me to change color, which I don't need to do, but it allows me to change the graphing style. From a line, you can shade above, you can shade below. The one I want is a tracer ball. Press the down arrow and press Enter for OK. And when we look at the graph, that tracer ball is going to trace the graph, and clearly the factored graph is different than the original because I made a mistake. And so going back to y equals, I can fix my mistake and hit graph. And notice the spinning ball here. That means something is happening in progress. We have to wait for that to finish. If you don't want to wait, one tip is under mode. You can graph simultaneously here instead of sequentially. But the other thing that you can do, whoops, let me get rid of that. The other thing you can do when you graph, if you're done watching it graph or you've made a mistake, you can press the on button to break your process of graphing, or you can press the enter button to pause the process of graphing. Here's the enter button. I paused, pressed it again to restart, press it again. I can also press on and just quit what I'm doing. Those are all options. Okay, back to our home screen. What about, what else do I have here? Oh, let's say that we are doing other things with templates. The only other thing I wanted to share with you with a template is that when you are inside a template, you might have to arrow out of the template to get out. Okay. That is what I think I have for the very basics on the home screen. Now what we're going to jump into is what's the best window. So let's say you're in Algebra 1 class and you're interested in graphing on your window. And the window button is going to show us our x min, max, y min, and y max, which this standard window is very, very helpful for most graphing situations. I'm going to clear out of these things here. And if I wanted to graph 2x minus 3, that standard window is going to work great. But it might not work so great if I wanted to graph 12x minus 37. And so what I would do in that situation is I would have students, I'm inserting the 1 here. I would have students decide what might be a good window. I might have to change my y min to, let's say, -50. Let's give it a try. Okay, and I can now see a little bit of a better situation in terms of my y-intercept, but notice what's going on my y-axis. I've got a lot of scale marks mushed together, and that's because I haven't changed my y scale. So if I were to make a y max of 50, I might want my y scale to be every 10. And now this is 12x minus 37. The other standard window that I like to use, there's other windows in the Zoom menu. We were already just using Zoom Standard. You might want to look at this window with a grid behind it. So doing second format allows you to turn on the grid. And when you look at this graph, whoops, am I in the standard window? I want to go back to Zoom Standard. Here we go. Zoom Standard. And with that graph grid, which I think is a very useful grid for students to understand slope, etc., the problem with it is you'll see that the grid lines don't make squares, they make rectangles. I can address that two ways. I can change it to Zoom Square, which will square off whatever my window is. But my other favorite window that I have is number 4, Zoom Decimal. And the Zoom Decimal window, let me just get rid of that 1 here. The Zoom Decimal window has a lovely, reasonable domain and range for use in many Algebra 1 graphs, and there's no distortion. Everything is squared off. The other wonderful thing about the Zoom Decimal window is when you trace, notice that the trace step is 0.1. The other items in the Zoom menu, there is number 9, Zoom Stat, and number 0, Zoom Fit, and these will adjust the window to, in the case of Zoom Stat, it will adjust the window to any scatter plot data that you're working with. And Zoom Fit will adjust the Y values, the Y min and Y max, to whatever the domain is of your X min and X max. You might also notice Zoom Memory. This allows you to go back to a previous window that you might have had before and you've changed it and you realize you changed it in a way you didn't want to do it. You can also store a favorite window and recall it later. So I like to sometimes double my Zoom Decimal window. Let's see one more reason why the Zoom Decimal window is wonderful. Let's say you have a rational function. Let's get our fraction template, and we want to graph x squared minus 3x minus 2 over x minus 2. I'm sorry, I want to do 3x plus 2. Okay, and for those of you who can factor pretty quickly, we've got x minus 1 over x minus 2, so we're expecting a whole at 2. Let's check it out. On the Zoom Decimal window, here's that whole. If we go to Zoom Standard, that whole is not going to be visible. So the Zoom Decimal window is my favorite window because it allows you to see the wholes and to utilize a square window. Okay, moving right along, let's go back to our home screen and let's talk about exponents. And let's say you're trying to develop the idea of what exponents actually do. I'm going to begin with 10 squared, and then I'm going to go to 10 cubed. I'm going to use the caret here for exponentiation. And then I want to do 10 to the 4th. And you might do this if you're trying to get students to first understand this idea of an exponent. It's multiplying out 10 4 times, 10 times 10 times 10 times 10. But here's an idea. We can use this home screen to iterate the same process. So if I take that last answer and now type times 10, enter, and then I press enter again, it's going to get me the next one, and the next one, and the next one. And if I keep going, we're going to end up in scientific notation here. And we can see that each time we multiply by 10, our exponent increases by 1. That's one way to use the home screen to understand exponents. I want to give you another way to work with exponents. In my y equals, I'm going to put in a fraction bar. Remember, it's alpha x or alpha y equals. And I'm going to put in 2 to the x over a 1. And you may say, Karen, why are you even bothering with a fraction? That will become clear in a moment. But 2 to the x as a power, we can take a look at that in our table. And I've done a lot of work with tables, and one of the most wonderful things I realized is that under table set, you can you can change the type of tables, and you can have the independent variable be asked for, and then the dependent variable be auto. And this is a way to make your tables dynamic. So here, if I start with 2 to, let's say, the 4th power, and then 2 to the 3rd power, and then 2 to the 2nd power, and then 2 to the 1st power, we can ask students what is going on as we take our powers. What's happening to our powers themselves? They are being decreased by 1. They're subtracting. And the results, what mathematical process is happening to the results? They're being divided by 2 each time. So if I were to put in a power of 0, reducing my power by 1, subtracting 1 from the exponent, I would expect that my result is going to be divided by 2. And it is. A 0 power is 1. Well, then what would we expect for a negative power? And another negative power. And you can really develop the ideas that are happening here using a dynamic table. There's much more you can do with tables, and there's a couple of activities in our documents folder for you. But moving right along, going back to our home screen, we had a bunch of different shortcut menus. We've already looked at the alpha y equals, and alpha window we're going to come to shortly because we're going to use some of these math operations when we talk about logs in a little bit. But these are shortcuts. All of these items exist in the math menu. Alpha zoom is going to let you make a matrix on the fly. And alpha trace is going to give you your y1, y2, your function notation. And so let's see how function notation is going to allow us to build some understanding with Algebra 2 students, let's say, or perhaps your curriculum has it with Algebra 1 students. Let's get a quadratic here. X squared minus 5x plus 6. And let's get our second function to be x minus 3. And I can go back and change my graph style. I no longer need that tracer ball. Don't forget to press Enter on OK. But now these functions are in my y1 and y2, which means from my home screen, if I do alpha trace, I can do y1 of some value. I can evaluate that function at some value. I can do y1 alpha trace at a different value. I can do y1 of y2. I can do function composition. And so there's a lot you can do with this. You can choose functions that are inverses. So let's change this one to 2x plus 3. And then my inverse function will be a fraction, x minus 3 divided by 2. And so now if I do y1 of y2 of 2, you notice I lost that ending parenthesis. The TI-84 doesn't mind. I'm going to get 2. And if I do y1 of y2 of something else, whoops, I lost that. Let me go back up. I hit clear instead of delete. Let's say I wanted to do y1 of y2 of a quarter. It's going to be a quarter. So inverse functions work. And you can also use function composition right here in a function composition and combination right here in y1, y2 in the y equals screen. So let's say I wanted to do y1 divided by y2 or y1 plus y2. Alpha trace, y1 plus y2 or y1 times y2. You can combine them and do function composition. And so you can see your first two functions. Interesting, two linear functions, when you multiply them, is a quadratic function. You can take a function and perform composition using other functions. So if I have x squared plus x minus 2, let me clear this one out and clear this one out. What will that look like if I do the absolute value of that? Alpha window has the absolute value function, so I can do absolute value of y1. Let's check this out. Okay, and so there you have that. You can also do other situations where you ask students to create a particular composition. The last couple of topics that I have for you are how to use inquiry with logs and complex numbers. And in the interest of time, I'm just going to show you a couple screens because I want to have time to give this back to Valerie. There we go. I can't get to it because my emulator is always in front. There it is. Okay, so what we can do with logarithms is from that window shortcut, one of them there is number 5, log base. And so you can ask the calculator, what is log base 2 of 64, let's say. And you can have students begin to understand what a log is by doing some computations and have them verbalize that log is actually giving you the exponent on the given base. If you're teaching change of base laws, don't forget to test kids on that without their calculators, since they can do logs of any base on their calculators. But so what I do here is I ask students to tell me what the log command does by having them work through several log operations. And then the other thing I like to do is I like to have students notice and wonder for log laws. So I'll give them these screens next to each other. What is log of 3 times 5, log of 3 divided by 5, and log of 5 to the 3rd power? And then next to that, what happens if you do log of 3 plus log of 5? Well, gee, that's the same as log of 3 times 5. And so they can notice and wonder and build those log laws for themselves. This also allows you to dispel any misconceptions that log of 3 times log of 5 is not the same as log of 3 times 5. I skipped over it really quickly, but this is another fun one that's in your handout. What happens if you do log of successive multiples of the same number? So if you do 2,220 and 2, you'll notice that you get very interesting results because of the way that the log base 10 works. And so that's another fun one. Again, I wanted to move along here. The last thing is complex numbers. Under our mode button, you can change your mode from real to a plus bi. Under real, if I take the square root of -49, I'm going to get an error. It's a non-real answer. But if I change my mode to a plus bi mode, and back to my home screen, I can arrow up so I don't have to type it again, and I can get 7i. I can do computations with complex numbers. The I is above the decimal point. So I times 1 minus I, for example. You can distribute that. Okay, so it can do the computations for you. And to wrap it up here, you can also have students building understanding by taking them through powers of I and interesting products. Here's some conjugates. Why does that work? How can they explain it? Before I pass the mic to Valerie, I just want to say that there's more in the documents folder on scatter plots as well as on geometry. So if you have other things that you didn't get covered here in my tour and that Valerie's going to do, please don't hesitate to see what's in the documents folder. Okay, sorry, Valerie, I think I went a little bit over.
That's okay.
And there you go.
All right, so I am going to share my screen with you. And here we go. Awesome. Okay, so I was answering some questions in the chat as we were going along. One question from the SmartView emulator was, when we have the TI-view on the side, do we have to have these screenshots? No, you can go to the drop down here and you can change to whatever you would like. So if you want a stat plot or whatever, then you can get that. I'm going to get out of that though. Okay, so where I am going right now is to talk about the transformation graphing app. And so another question in the chat was, what is the difference between the C and the CE calculators? You're going to see that with the transformation app. So for one thing, to open the transformation graphing app, no matter what calculator you have, you're going to go to the apps button. I'm obviously in the CE screen, and you can see the black screen. I believe Karen had a white screen, so there's different views that you can have for your calculator. I am going to press the up arrow instead of the down arrow, so I can just get to the lower letters quickly. And when I press enter, I have my transformation. I don't know why it's not showing up over here though. That's strange. But I'm in my transformation graphing app. And so if I go to y equals, again, I'm not sure what's going on over here, why this isn't showing up. But I can see that I have my plots on, so I'm going to turn those off by pressing the up arrow and enter. And then coming back down, I'm going to clear out that equation that I have. But if you'll notice, I have, in addition to all the plots, I also have quit app because my transformation graphing app is showing. So let me see, maybe I can do it. Nope, that's not going to do it. Okay, I guess it just wanted to reset. So now I can quit the app if I want, but I haven't graphed anything, so you can see what I'm doing. So let me just type A X plus B. Now this is for the transformation graphing app, the general linear equation in slope-intercept form. Why is it not mx plus b? Because the transformation graphing app reserves the letters A, B, C, and D for use for attributes that can be changed in some way. So if I tried to type mx plus b, the transformation graphing app wouldn't understand what m was because that's not how it was programmed. So now if I press graph, looks like my A value is 86. Well, let's see what happens when I press the left arrow button. And this is not going through very many changes. Here we go. If I go a little faster, this is taking way too long. Let me change it a different way. I'm going to go to setup. So setup is a it's called a soft key. It's a key that's on your screen, and you have to access any soft key on your 84 calculators. You have to press the hard key directly below it. So I'm going to press the graph key. And so I want my A value, let's say, to be 1, be a little bit more reasonable. And so now if I go back to my graph, my A value is now 1. So if I press my right arrow button, as you can see, my slope is increasing. If I press my left arrow button, my slope value is decreasing. And if I press my up or down arrows, then I can now go to my y-intercept and make changes there as well. So that's pretty nice. So we want to make sure we turn off our plots, we eliminate any equations before we access the app. Now to exit the app, if you have an 84 plus CE calculator, or if you have an 84C calculator, you can exit the app from your y equals because it says quit app. But if you have an 84 calculator, let me go to the 84 emulator right quick. 84 plus. And I'm in that app. I don't have those options at the top. So if we have an 84 plus calculator, then we have to go back to the apps button. And then again, I'm going to press that up arrow instead of the down arrow so I can get to my lower letters in the alphabet. And then enter for transform. And do I want to uninstall? Yes, it doesn't really uninstall. It just turns off the app. So now if I go back to y equals, then I still have my ax plus b that I typed in previously. But when I go to graph, I don't have any options because I've turned the app off here. In the 84 plus C, again, you do have that quit app, but there is a little difference because with the CE, let me show you something on the CE that the C does not have. And that is if I arrow all the way over to the left side where I have this play pause mode for Y1 and Y2, if I press enter, then I can change my color, which I can do on the C. I can change from play pause to just play where it would just automatically advance. But then I can also choose my equations here. We don't have that on the C calculator. So the CE is nice for just general equations with the transformation app. So I'm going to be using this one shortly. So I'm just going to go down here to OK. All right. So the next thing we're going to talk about is 84 Activity Central on the TI website. So let me pull that up. And here, go to the general Texas Instruments website, which, hello, not that. It's education.ti.com. It is not www, just education.ti.com. And once you're there, we'll go to Activities. We'll go to 84 Activity Central. And as you can see, there's lots of different subjects here, including science. So we could click on a subject area, click on a topic, and here are all the activities in solving linear inequalities. So if we click on one of those activities, then we'll have a little bit of more information about that activity. There'll be a place to download anything that needs to be downloaded. So that's very, very nice. Also, a little preview of what to expect on the calculator. Another option here is to search by standard. So I'm back here over here on the left. And if we click on standard search, then you select your standards. I teach in Texas, so I'm going to go down to Texas. And you select whatever grade you want, whatever subject you like, and then search. And as we search, what's going to come up are your state standards. And if you see anything linked in blue, then there are lots of activities that go along with that particular standard. So that's very nice. Now, I've already downloaded an activity because I wanted to show you how you can send that activity to your emulator and or to another calculator. So I'm still in my SmartView. Let me pull up what I have here. I downloaded an Algebra 2 activity called Building Curves, and there is a calculator document. I know that because of the suffix 8xp. And so in the emulator, this is where we've been living, but you also have this other option over here on the far, far left of my screen, and that is everything that's on your emulator. So I'm trying to open that up. and it's slow. There we go. And so if I want to add this activity that I just downloaded to my emulator, all I'm going to do is grab it. Okay, if it's going to let me grab, here we go. Nope, it wants to be difficult. There we are. And drag it, and you drop it in there. And so if I have something with the same name, which I do because I've already downloaded it, then it would just override that. So now I'm sending it, I've received it, and I can then pull up this activity on my calculator. And this one happens to be a program. So if I go back to my emulator and program, I have that building curve program. I could open that up and I can follow the instructions that were online as far as what to do with that. Now, also, if you'll notice in those downloaded activities here on the right of my screen, I have a student document, student PDF, and teacher document. All the Texas Instruments activities, whether they have student and whether they have calculator documents, they will have student documents and in document form and PDF. So if you want to make any changes, then you can do that. And it's very nice to have the teacher document, of course, for answers and other helpful hints. So that is just a little overview of the SmartView. I'll come back to that in just a little bit. So let me quit out of here. And I'm going to pull up TI Connect, because if you have an activity, let me turn my calculator on here. If you have an activity that you want to download to your student calculators, then you'll need TI Connect. And the TI Connect software I'll talk about as far as where to get it. That's going to be in a little handout after our webinar is posted. You'll see information about that. But I've already plugged my calculator up to my computer, so I can see my calculator here. If I take a screen capture of my calculator that's plugged up, I've opened up my programs here, so I've already downloaded that build curve program. And let me pull up a Word document. So as Karen demonstrated, you can grab and drag, just like Karen showed you earlier, into a Word document from TI Connect as well. So that's very nice. All right, another nice feature of TI Connect is, as I said, we can see we can drag a downloaded activity onto our calculator. So I'm going to click on the second icon here where I can see everything that's on my calculator. And if I want this build curve activity on my calculator, again, I'm just going to grab it, drag it, and drop it. And if I had more than one calculator connected right now, I could drag this activity on all of my connected calculators. So I'll go ahead and send that. It is sending, and that build curve activity is now overridden because I already had it there. Now, another feature of TI Connect is the ability to program, because you can program on your 84 calculator, but it is a bit easier to program on the TI Connect software. So I already have a program here, and we're going to talk about that. Actually, I have two programs here, and we're going to talk about those briefly. So let me go back to my PowerPoint. So Activity Central, we talked about that. TI Connect software, we talked about the 3 workspaces there. And this is free software. So again, in the handouts that will be associated with this webinar, you're going to get that link as well as other information on how to use the software, because I know we're going pretty fast. So planning to program with I had a focus on transformations of functions. So with programming in general, you want to think about pseudocode, or just what actions do I want the calculator to perform. Now, why program, you might say? Well, let me just say from teaching Algebra 1. I don't know about your students, but my students in Algebra 1 tended to not want to think very deeply or very hard or very logically. And programming will force students to do just that. It will force them to think logically. And so I had my students in Algebra 1 do little programming activities called 10 Minutes of Code, and those are on the TI website as well. So I'll show you that website in just a second, but just for the program that I'm going to demonstrate with you, which involves a random linear function that's on the screen, and then we can use the transformation app to match that random function. So you can have lots of good conversations about your kids or with your kids about the process of transformations. So in general, this was my thought process in programming. What's helpful to have on the screen? Well, you want to have those items for sure. What's not helpful to have on the screen? You don't want to have those items. And so my code had to address all of this. And so you'll see that as we look at the code. And then there might be some additional items to consider regarding a potential transformation program. You might want to randomize parameters. You might want to have the program enter the equation and graph the equation for you. An optional item would be to include the parent function. So if you didn't want to use the transformation app, let's say, but you just wanted to have a conversation about your or with your children about how is this random graph changed from the parent, you might want to include the parent function. So here's the code, at least the first 7 lines of code. The first line turns off all functions. We turn our pipes off. We clear any drawings. We turn off any background visuals because you can't put pictures on the CE calculators and C calculators. We want to turn on our axes so we can see. We want our grid lines on. Zoom decimal, as Karen mentioned, is very, very nice. So if you perhaps wanted your students to trace, Zoom decimal would be a very nice window for you. Then continuing with the code, because we can save values to variables, we have no idea, especially if it's a classroom calculator, if the student has saved some number to our variables that we're using. I use V, if you'll notice in line 12 there, to represent the slope, and K to represent the y-intercept. Why? Because again, if I'm using the transformation graphing app, I know that A, B, C, and D are already reserved, so I could have said MX plus K, I suppose, but my name is Valerie, and so I wanted a V, so that's why I put the V there instead of an M. So you can really program however you like, using whatever variables you like. And then we have to take a string value. I know I'm going through this fast, I'm so sorry, but there is a document in your items that you'll have when this webinar is posted that goes through where to find all of these areas where I've entered the code and why. So we have to take the string item that I saved and convert that to an equation. So that's the first line here. We want to display our graph, and then the rest of the lines of code are if you wanted to have the parent graph as well. So you can change the program that will be in our documents if you like. So let's go to, let me get out of here. Let's go to the code. There's my code. I'm going to run that code now on my emulator. So I'm going to program. My code is called trans1 for my linear. And I'm going to go ahead and run that by pressing enter. And that is just a random graph. If we go to y equals, I have turned off my transformation graphing app because that was one of my lines of code that I wanted anything that was already entered to be turned off as far as equations. So I'm going to go ahead and turn that back on by hovering over the equal sign and pressing enter. And now when I press graph, I have this blue line here that represents the transformation graph line and my random graphed line, which as you can see in y equals, the students can't see where that equation is. So they truly have to talk about, or you as a teacher lead them through talking about, well, what would we have to do in order to match this slope? What would we have to do to this graph the blue graph here in order to match this y-intercept. And so the transformation graphing app, since my A is selected, if I want to increase my slope, then I'll press the right arrow. If I want to decrease my slope, then I'll press the left arrow. So looks like I'm about parallel, so you can talk about parallel lines as well. And now if I'll press the down arrow, then I'll want to probably increase my y-intercept. And now I have matched the graph. If we had the program with the additional parent graph, then again, you would have 3 lines. But you may or may not want to use a transformation graphing app in that case. All right. So from here, if we wanted to, let's say, have the same idea for transformations, but use quadratics, what do we have to do? Well, probably change 3 parameters instead of 2. And then also we'd have to change our general equation in our transformation graph. You will have that quadratic transformation program as part of your materials. I know we're about to run out of time, and I did want to show you some things on the Texas Instruments website, but that's just a little taste of transformations and programming that you can do with your kids. So I mentioned that the Texas Instruments website has 10 minutes of code activities, and so where can we find those? On the Texas Instruments website, right here. In one of your handouts, we'll talk about 10 minutes of code and we'll give you the URL to get there. And so if we go to the 84 Plus technology, then we have various activities that you can download or your kids can download and just work through. How does coding work for lots of different situations. Also on the Texas Instruments website, there are links to resources for distance learning, and lots of resources are available to you, free software, free trial software, Chromebook information, calculator loans. I know I was answering someone in the chat about calculator loans, how to disinfect TI products, and video resources. And I know I'm out of time, so it was very nice to speak with you, but I do need to now give Michael the ball.
Thanks so much, Valerie and Karen. So with the last little bit that I do have remaining, I do want to share one thing from our website, more resources. This is, I think, the last one that we're going to show you tonight. But on our website, education.ti.com, if you click on the resources tab at the top, one thing that you may find helpful is the tutorials. I like these because I can go back under graphing tutorials and say, oh, I have the TI-84 Plus, and I can look through all these tutorials, such as how to update my operating system on my handheld, stuff that I probably haven't done in a really long time. But there's all these other really short, free videos that you can watch. So please feel free to visit our website, education.ti.com, to learn a little more about some of those resources. So I know that we've talked about these documents that are coming up, and I'm ready to give those to you. So to receive the documents for tonight, as well as the certificate of attendance, go ahead and click the links in the chat window. And if you miss these links for any reason, you'll automatically get a follow-up email in a couple days with those links. Also will be a link for the recording. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. If you have any additional questions tonight that we didn't have a chance to answer, please feel free to reach out to us. Give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. Karen and Valerie, thanks so much for everything you shared tonight. I know that there was a lot that we packed into this short 1-hour webinar, and I'm glad it's recorded. That way we can go back and follow along at our own pace. So thanks so much for everything you brought to our attention tonight.
Mike, it was our pleasure. I've shared mine and Valerie's emails and Twitter handles in the chat for anyone who has further questions.
Yes, please do let us know, and it was wonderful to work with y'all today.
I echo both of those. Thanks to everyone for joining us. We hope to see you back online next week. Please stay safe.